Le Chatelier's principle and its applications in industrial processes. So one of the principal goal in every manufacturing process is that maximize the yield of the product. In order to maximize the yield of the product, means in order to obtain the product in large amount, what are the favorable conditions in terms of temperature? How should be the temperature? How should be the pressure? Low pressure or high pressure? High temperature or low temperature? Or in terms of concentration of the reactants and products? What are the favorable conditions for the maximum production of a substance? This principle helps us. Le Chatelier's principle. So before we go to Le Chatelier principle, I just want to remind you what is an equilibrium means. Equilibrium of a chemical reaction means it's a stable stage during the course of the reaction. Consider a general chemical reaction R in equilibrium with the P product, where R is the reactant, P is the product. There exists an equilibrium between reactants and product. That means there occurs forward reaction and backward reaction. At equilibrium, the rate of forward reaction becomes equal to the rate of backward reaction. Right? Rate of forward and backward reactions are equal at equilibrium of a reaction. That means if we have taken, if 100 moles of reactants take part in the reaction, 100 moles reactant gets converted into product. In the backward reaction, what happened? Same amount of products converted back to reactants also. That means 100 moles products gets converted back to the reactant. So because the rate of both the forward and backward reactions are equal, there is no net reaction. No net reaction takes place because the rates are equal. The conversion of reactants to product and the products back to reactant occur in the same rate. So there is no net reaction. There occurs both forward reaction and backward reaction takes place, but no net reaction because their rates are equal. At equilibrium, concentration of reactant and concentration of product remain constant. There is no change in the concentrations of reactants and product at equilibrium. This is a stable state. The system wants to be in equilibrium. It does not want to disturb the equilibrium. So this is about the equilibrium of a chemical reaction. Now, this equilibrium of the reaction can be affected by a change of temperature. If you change the temperature, if you change the pressure of the reaction mixture, if you change the concentration of reactant or product of this equilibrium, the equilibrium will be affected or equilibrium will be disturbed. The equilibrium stage will be lost. The system will not be equilibrium if you make a change in any of these conditions like a temperature, pressure, concentration, etc. The system do not want to disturb the equilibrium. So once the equilibrium is disturbed with the change we made, the system want to attain the equilibrium back. In order to attain the equilibrium, the system net reaction takes place in some direction. There would be some rearrangement in the reaction mixture and net reaction takes place either in the forward direction or in the backward direction in order to undo the effect of that change, in order to nullify the effect of that change. That means for a system in equilibrium, if we change its temperature, pressure or concentration of the reactants or product, the equilibrium will be disturbed. The system will try to attain equilibrium back by doing some rearrangement in the system, and net reaction takes place in some direction in order to nullify or in order to cancel the effect of the change we made. Net reaction occurs in some direction till a new equilibrium is obtained. This is what Le Chatelier's principle. For a system, if a system in equilibrium is subjected to a change in its concentration, if you make a change in its concentration or pressure, or if you make the change, we change the temperature of the system in equilibrium, what the system do? System will rearrange itself. There would be some rearrangement. Net reaction will occur in some direction, either in the forward direction or in the backward direction. Why? In order to nullify the effect of that change. Nullify means in order to cancel or in order to undo the effect of that change. Whatever be the change we made, the system try to undo the effect of that change by making some reaction in a particular direction, and a new equilibrium will be attained. That means if you make any change in this reaction at equilibrium, the equilibrium will be lost. Equilibrium is disturbed. Net reaction takes place at some direction. In which direction? That depends upon the change we made. In order to nullify the effect of that change, net reaction takes place in some direction. For example, if you make a change in the concentration, if you increase the concentration of some substance that take part in the chemical reaction, either reactant or product, the system will try to decrease the concentration. If you increase the concentration, system will try to reduce the concentration, and net reaction takes place in that direction where the concentration of that substance decreases. If you reduce the concentration of a substance, the system will try to increase the concentration by causing the reaction to occur in that direction where the concentration of that reactant or product increases. If you increase the pressure, system will try to reduce the pressure, and net reaction takes place in a direction where pressure decreases. This is what Le Chatelier's principle. By applying this principle, we can predict or we can determine what are the favorable conditions to produce maximum amount of product. In order to increase the production of the substance P, what are the conditions? Should we apply high pressure or low pressure, or high temperature or low temperature? And what to do with the concentration? The favorable conditions which can maximize the product yield can be determined based on Le Chatelier's principle. So, if a system in equilibrium subjected to a change in its temperature, pressure or concentration, the system will rearrange itself in order to nullify. Nullify means cancel or undo. Nullify the effect of that change. If you try to increase, the system will try to reduce that change. Clear, children? Now let us explain the effect of concentration change on equilibrium. How the equilibrium is affected by the change of concentration. Effect of change of concentration on equilibrium. Means for a system in equilibrium, we change the concentration of reactant or product. Consider the general reaction R, equilibrium P. Addition of R. How the equilibrium will be affected by the addition of reactant substances. Reactant substances added more into this reaction at equilibrium. We add more amount of reactants into it. That means we increase concentration of reactant. If we increase the concentration of reactant, addition of R means if we increase the concentration of the reactant, the system will try to decrease it. The equilibrium will be lost. Equilibrium is disturbed. The system try to reduce the concentration of reactant, and net reaction takes place in the direction where reactant concentration decreases. In which direction reactant concentration decreases? In which direction reactants are getting converted to product? In the forward direction, right? In the forward direction, reactant concentration decreases because reactants are converted to product. That means if we increase the concentration of the reactant, the system try to decrease it, means decrease the concentration of R, and net reaction takes place in which direction? Where reactant concentration decreases, in a direction where reactant concentration decreases. We know reactant concentration decreases in the forward direction. Forward direction reaction takes place and a new equilibrium will be attained. Or we can say the equilibrium is shifted to forward direction. So by the addition of reactant, the equilibrium will be shifted in the forward direction. That means forward direction reaction will take place because we added R. System do not want this change. System try to reduce the concentration of R, causing the reaction to move in the forward direction, because in the forward direction reactant concentration decreases. So equilibrium will be attained, a new equilibrium will be attained by shifting the equilibrium to in the forward direction. Now removal of P. So addition of R by adding more amount of reactant, the forward direction reaction will take place and the production of P will increase. So in order to increase more amount of the product, what to do? Add reactant molecules continuously. The addition of reactant molecules will shift the equilibrium in the forward direction. More amount of P will be obtained. Products will be obtained. Product amount can be increased. We can maximize the yield of the product by adding more and more amount of reactants. Now removal of P. Removal of product P. For this system at equilibrium, if you remove P from the reaction mixture, means as soon as P is formed, the P is removed from the reaction mixture. That means removal of P means we reduce or decrease concentration of P. If we decrease the concentration of P, the system will try to increase it. In which direction? Product concentration increases. Product concentration increases in the forward direction, right? The reaction will occur in the forward direction till a new equilibrium is attained. Or we can say the equilibrium will shift in the forward direction. That means in the direction of formation of product, means more and more product can be obtained. Means how to maximize the product formation? By this is thus another favorable condition, removal of product from the reaction mixture. If you remove the product, equilibrium will be shifted in the forward direction. System will try to increase the product concentration. In order to increase the product concentration, reaction takes place in the forward direction. More and more amount of product will be formed. So these are the two conditions. Favorable condition to maximize the yield of product in any chemical reaction at equilibrium. How to maximize the product? Addition of reactant. Constant addition of reactants into the reaction mixture. Equilibrium will be shifted in the forward direction. More amount of P will be obtained. Second condition, removal of product. As soon as the product is formed, the product is removed continuously. Continuous removal of product from the reaction mixture. Again shift the reaction in the forward direction. So these two are two favorable conditions. Addition of reactant and removal of product will increase the amount of P. Consider Haber process. We know Haber process is a very important industrial process. It is the manufacturing process of ammonia. Ammonia manufacturing process is called Haber's process. Production of ammonia. The raw materials are nitrogen and hydrogen. combines, there is an equilibrium between the reactants and product is ammonia. 2NH3, 3NH2. This is the reaction. Nitrogen combines with hydrogen and form ammonia in the forward direction. In the backward direction, what happens? Ammonia decomposes to give nitrogen and hydrogen back. At equilibrium, there is no net reaction. For this system in equilibrium, if you add addition of N2 and H2, if you add more amount of hydrogen, more amount of nitrogen into this equilibrium, what would happen? That means nitrogen and hydrogen concentration of nitrogen we increase, concentration of hydrogen we increased. How the equilibrium will be affected? Means more amount of reactant we add, nitrogen and hydrogen added more and more into this equilibrium. What happens? The equilibrium will be disturbed. Equilibrium is disturbed. System is no longer in equilibrium and system do not want this change. System will try to decrease concentration of nitrogen and hydrogen. Net reaction takes place in that direction where concentration of nitrogen and hydrogen decreases. In which direction concentration of nitrogen and hydrogen decreases? In the forward direction, right? In the forward direction, nitrogen and hydrogen combines and form ammonia. That means nitrogen and hydrogen concentration decreases in the forward direction. So what happens? Equilibrium will be shifted in the forward direction and a new equilibrium will be attained. Forward reaction will take place till a new equilibrium is formed. Means more amount of ammonia. In forward direction, ammonia is formed. So more amount of ammonia can be obtained. Now, removal of ammonia. If you remove the ammonia which is formed as a gas can be cooled. On cooling, ammonia will liquefy. Ammonia will liquefy on cooling. And liquid ammonia can be removed from the reaction mixture continuously. So the ammonia gas formed during the reaction is cooled and liquefied and removed from the reaction mixture continuously. Removal of ammonia. How the equilibrium will be affected? Removal of ammonia means ammonia concentration of ammonia we reduce. If concentration of ammonia decreases, system try to increase ammonia concentration. How to increase ammonia concentration? By occurring the reaction in the forward direction. In order to increase ammonia concentration, reaction takes place in the forward direction. Again, forward reaction takes place. Means more ammonia will be produced. So, how to increase the amount of ammonia product, yield of ammonia? How can we increase or maximize? Adding nitrogen and hydrogen. Constant addition of nitrogen and hydrogen into the reaction mixture. And continuous removal of ammonia. Ammonia gas formed during the reaction is continuously removed by liquefaction. Those the conditions favor the maximum production of ammonia. Both these conditions, under these conditions, what happens? Forward reaction will take place. More and more ammonia will be produced. Or if you consider the removal of hydrogen, how the equilibrium will be affected? If you remove hydrogen, that means hydrogen concentration we reduce. If hydrogen concentration decreases, how this equilibrium will be affected? Equilibrium will be lost. System try to increase hydrogen concentration. In order to increase hydrogen concentration, which direction the reaction will occur? The reaction will occur in that direction where hydrogen concentration increases. Hydrogen concentration increases in the backward direction, right? What happens? Reaction takes place in the backward direction till a new equilibrium is attained. So, removal of hydrogen will cause the reaction to occur in the backward direction. means ammonia production will be reduced. So this is not a favorable condition for the maximum production of ammonia. Clear? And if addition of ammonia into this reaction mixture, if you add more amount of ammonia, that means if the ammonia concentration we increase, system will try to reduce the concentration of ammonia. How to reduce the concentration of ammonia? Shifting the reaction in that direction where ammonia concentration decreases. Ammonia concentration decreases in the backward direction. Again, backward direction takes place. Ammonia production will decrease. So these two are not favorable condition to maximize the ammonia production because backward reaction takes place. So this is the effect of change of concentration on equilibrium. Now let us explain the effect of change of pressure. Effect of change of pressure on the equilibrium of a chemical reaction. We know out of solids, liquids and gases are highly compressible, right? Solids and liquids are practically incompressible, or pressure has significant effect only on gases. Pressure has no effect on solids and liquids. So here we consider chemical reactions which involve gaseous reactants and gaseous product. Clear? Now we have studied ideal gas equation, right? For ideal gases, what is the ideal gas equation? PV equal to nRT, where we know P is the pressure of the gas, N is the number of moles, right? V is the volume, R gas constant, T is the temperature. So P the pressure, N is the number of mole. Tell me how the two are related. Pressure and number of mole. When number of mole increases, pressure also increases. When number of mole decreases, pressure decreases. That means the pressure is directly proportional to number of moles, right? Pressure and number of mole of a gas directly related. Consider Haber process again. Nitrogen, which is a gas, combines with hydrogen, again a gas, equilibrium 2NH3. Ammonia is also formed as a gas. Haber process. Tell me how many moles of nitrogen take part in the reaction? 1 mole, right? 1 mole nitrogen. How many moles of hydrogen? 3 moles. How many moles of ammonia are formed? 2 moles. Right? Total number of moles of the reactant. What is the total number of reactant? 1 mole plus 3 mole, 4 mole. 4 mole changes to 2 mole products. That is how the change in the number of mole in the forward direction decreases. Decreases to 2 mole. Right? Number of mole decreases in the forward direction. So just here we have written pressure and number of mole directly related. Number of mole decreases in the forward direction means therefore pressure of the gas molecules also decreases in the forward direction, right? Now let us consider high pressure. How high pressure will influence this equilibrium of Haber process. That means high pressure means if pressure increases, if we increase the pressure of the system, means pressure over the reaction mixture we increased, the equilibrium will be disturbed. The system is no longer in equilibrium. The system will try to reduce the pressure. How? By shifting the reaction in that direction where pressure decreases. If you increase the pressure, system try to decrease pressure, right? System will try to decrease the pressure and shift the reaction in that direction where pressure decreases. If you increase the pressure, equilibrium will be shifted in a direction where pressure decreases. In which direction pressure decreases? Pressure decreases in the forward direction, right? So in which direction the reaction will occur? The reaction will occur in the forward direction. Forward direction reaction will take place and a new equilibrium will be attained. Forward reaction means for more and more ammonia can be produced. So a high pressure if you apply on this reaction, forward reaction will take place. More and more amount of ammonia will be produced. On the other hand, a low pressure, if you reduce the pressure over the system, how low pressure influence this equilibrium? Means if we reduce the pressure, if the pressure decreases, system will try to increase pressure and shift the reaction in the direction where pressure increases. See, pressure decreases in the forward direction. That means pressure increases in the backward direction. So equilibrium will shift in the backward direction. Backward direction reaction will take place. Means ammonia production, ammonia formed is converted back. Ammonia production will reduce. So tell me, which is the favorable condition to maximize ammonia production? High pressure or low pressure? High pressure, because high pressure forward reaction. High pressure favors forward direction reaction. More ammonia will be produced. But low pressure, what happens? Backward direction. The reaction will take place in the backward direction. Production of ammonia will be reduced. So in order to maximize the yield of ammonia, what to do with the pressure? We need to apply high pressure. So in a similar way, we can predict the effect of pressure on the system knowing the stoichiometry of the reaction. Let us take another example. Consider the decomposition of N2O4, dinitrogen tetraoxide. Equilibrium 2NO2. N2O4 is a gas, NO2, nitrogen dioxide is again a gas. So this is a gaseous reaction. Tell me how many moles of the reactant take part in the reaction? 1 mole, right? Only 1 mole. How many moles of products are formed? 2 mole. 2 moles of the products. So number of mole changes from 1 mole to 2 mole. That means number of mole increases. In which direction? In the forward direction. Number of mole increases means pressure also increases in the forward direction, right? Pressure of the reaction mixture increases in the forward direction. Now let us explain how the effect of high pressure. If you increase the pressure, system will try to decrease it. Shift the equilibrium in that direction where pressure decreases. In which direction pressure decreases? Pressure increases in the forward direction. That means pressure decreases in the backward direction, right? So the reaction will be shifted in the backward direction. Backward reaction will take place. The production of NO2 will be reduced. Low pressure. How the system will be affected by low pressure? That is, if you reduce the pressure over the reaction mixture, system will try to increase the pressure. Shift the reaction in the direction where pressure increases. We know pressure increases in the forward direction. So the equilibrium will be shifted in the forward direction. Means more amount of NO2 will be produced. So what is the favorable factor for this particular reaction in terms of pressure? High pressure or low pressure? High pressure, backward reaction. Low pressure favor forward direction, forward reaction. So low pressure is favorable. To maximize the amount of NO2 production, low pressure is favorable condition. Clear? So this is the effect of change of pressure. Now we consider another example. Consider the reaction H2 plus I2, H2 gas, I2 gas, equilibrium 2HI. How many moles of reactant? 1 mole H2, 1 mole I2, 2 mole HI are involved in the reaction. So total number of moles of reactant 1 plus 1, 2 mole. 2 mole to 2 mole. See, number of moles remains the same. Number of moles remains the same on either side. That means number of moles and hence pressure remain constant on either side of the equation, right? Same number of moles involved, left side and right side. So pressure also the same on left and right, means number of moles and hence pressure remain constant. So for these reaction in which there is no change in the pressure on either side of the equilibrium, pressure has no effect. Pressure has no effect on such equilibrium. If the number of moles on either side of the equation remains the same, pressure has no effect on such equilibrium. Now let's consider another reaction. Carbon, which is a solid, combines with carbon dioxide, which is a gas, to give 2CO, carbon monoxide gas. Here you can see one of the reactant is a solid substance, carbon. Carbon dioxide is a gas and carbon monoxide, the product, is also a gas. How the system will be affected by the increase and decrease of pressure? See, here we need to consider only the gaseous reactants and products, right? So carbon, which is solid substance, the number of moles of this carbon we don't consider. We consider only the gaseous reactant, that is carbon dioxide. How many mole is involved? 1 mole. 1 mole of gaseous carbon dioxide changes to 2 mole of carbon monoxide. So pressure of this reaction increases, right? Number of moles increases or pressure increases in forward direction. Pressure increases. So tell me, if you increase the pressure, increase of pressure, how the system will be affected? That means high pressure. How the system will be affected by high pressure? If you increase the pressure, system will try to reduce the pressure. Shift the equilibrium in the direction where pressure decreases. Pressure decreases in the backward direction. So the reaction will take place in backward direction. Production of CO will be reduced. So low pressure. What happens at a low pressure? At a low pressure, the system will try to increase the pressure. If you reduce the pressure, system will try to increase the pressure, shifting the equilibrium in the direction where pressure increases. Pressure increases in the forward direction. So forward direction reaction will take place. Forward direction, the reaction will occur. So more amount of carbon monoxide can be produced. So if a chemical reaction is given to you, you will be able to identify whether pressure has an effect on that equilibrium. And if there is an effect of pressure on that equilibrium, how the how pressure affect that equilibrium, in which direction reaction will take place, we can predict based on Chatliers principle. And we can also predict whether pressure has a role on that equilibrium. If there the number of moles remains the same on either side of the equation, pressure has no effect. If there is a change in the number of mole, pressure has significant role. And how pressure affects that equilibrium, that also we can determine based on Chatliers pressure. So this is about effect of change of pressure on the equilibrium of a chemical reaction. After watching this video, I want you people to do exercise question number 726. You can try. It is based on pressure. How the equilibrium will be affected by pressure change is explained. Clear, children? So this you can do as homework. Exercise question 726. Now the next one, the effect of change of temperature on equilibrium. Effect of change of temperature on equilibrium of a chemical reaction. Depending upon during a chemical reaction whether heat is absorbed or released, we have two types of reaction. You might have studied exothermic and endothermic reaction. Reactions are of two types: exothermic chemical reaction and endothermic reaction. What are exothermic reaction? Exothermic reactions means reactions during which heat is liberated. The reactions which liberate heat are called exothermic reaction. For example, for the general reaction, R gives P. Along with the product, some amount of heat also liberated. Heat is generated as a result of this reaction. Such reactions are called exothermic reaction. Now there are some reactions called endothermic. What is the meaning endothermic reaction? During endothermic reaction, heat is absorbed. The reactions during which heat is absorbed are called endothermic reaction. That is, the reactant molecule absorb heat and produce product. Endothermic reaction. Endothermic reaction, heat is absorbed. Exothermic reaction, heat is produced. Effect of temperature on exothermic and endothermic reaction are different. Let us consider an exothermic reaction first. Consider an exothermic reaction during which heat is produced. This is the general equation. Dear children, tell me in which side of this equation, consider an equilibrium, in which side, left side or right side, temperature higher? Temperature is higher on which side, left side or right side? See, here in the right side, heat is produced, right? So, temperature is higher in the right side, lower in the left side, right? So, how the change of temperature in the forward direction? Temperature in forward direction, temperature increases. Correct? Temperature increases in the forward direction. Now we have to think of high temperature. If you apply high temperature, temperature we increased. If temperature is increased, equilibrium is disturbed. Net reaction takes place. System will try to decrease temperature. In which direction temperature decreases? Temperature increases in the forward direction. Temperature decreases in the backward direction, right? So equilibrium will be shifted in which direction? Backward direction. Clear? So high temperature, what happens? For exothermic reaction, if you apply high temperature, if you heat the reaction mixture at equilibrium, backward direction reaction will take place. Means amount of product will be reduced. Now low temperature. How low temperature will influence this equilibrium? That means if we reduce the temperature, if temperature reduced, temperature of the reaction mixture we reduce, means reaction mixture is cooled. System will try to increase temperature. In which direction temperature increases? Temperature increases in the forward direction. So forward direction reaction will take place. Reaction occur in the forward direction and a new equilibrium will be attained. So equilibrium shifted in the forward direction. More amount of product will be formed. So which is favorable factor for exothermic reaction? In order to maximize the product formed, high temperature or low temperature? If you apply high temperature, backward reaction will occur. But low temperature, the reaction will proceed in the forward direction. More amount of product will be obtained. So which is the favorable condition? Low temperature. But many reactions are slows down at low temperature. If the temperature is very low, the reaction rate will reduce. The reaction will be very slow. Such reactions are very difficult to occur. If the reaction rate is very slow, such reaction will not occur. So an optimum temperature that is suitable for the production of the substance product will be chosen. So extremely low temperature we cannot take for, even though it is the favorable condition to maximize the product formation, extremely low temperature will cause the reaction to occur very slowly. So an optimum temperature, not too high, not too low. An optimum temperature will be selected for most of the exothermic reactions. Clear, children? Now let's see the endothermic reaction. In the case of endothermic reaction, for endothermic reaction means heat is absorbed. For endothermic reaction, during which heat is absorbed. How to represent the general reaction? Reactants absorb heat and converted to product. Now in this reaction, tell me the temperature is higher which side? Left side or right side? See, in the left side, reactant plus heat means temperature is higher here in the left side. Here temperature low. That means temperature in the forward direction decreases. Temperature decreases in the forward direction. Correct? Now let us consider high temperature. So for this reaction, endothermic reaction, if the temperature increased, system will try to decrease the temperature. Temperature decreases in which direction? Forward direction. What happens? Forward direction. The reaction will proceed in the forward direction and attain a new equilibrium. So more amount of the product can be obtained at a high temperature. Now if the temperature is low temperature, that means if you reduce the temperature, system will try to increase the temperature. Temperature increases in which direction? Backward direction. So backward direction reaction will take place till a new equilibrium is attained. Clear, children? If temperature decreases, backward direction reaction will occur. So which is the favorable factor for maximize the amount of the product for endothermic reaction? High temperature. High temperature is the favorable condition. At a high temperature, forward direction reaction will take place. The equilibrium constant Kc is a constant at a constant temperature only. So when the temperature varies, Kc value also vary. Kc value depends on temperature. Kc value will not change with the change of pressure or change of concentration, but Kc value will vary with the temperature. For an endothermic reaction, when temperature increases, forward direction reaction will take place. When temperature increases, the reaction will proceed in the forward direction. So more amount of product will be obtained. Greater the amount of product, greater will be the Kc value. Kc value increases. At high temperature, for endothermic reaction, forward direction reaction takes place. In forward direction, more amount of product is formed. Product concentration increases. When product concentration increases, Kc value also increases. So Kc value for endothermic reaction increases with the temperature. And at low temperature, what happens? Kc value backward direction reaction takes place, means product concentration decreases, reactant concentration increases, Kc value decreases. For endothermic reaction, Kc value vary directly with the temperature. For endothermic reaction, Kc value and temperature directly related. Higher the temperature, greater the Kc value. Lower the temperature, lower the Kc value. For exothermic reaction, it is vice versa. Means for exothermic reaction, Kc value and temperature are inversely proportional actually. For exothermic reaction, if you increase the temperature, backward direction reaction will take place. That means Kc value will decrease. For exothermic reaction, Kc value and temperature are inversely proportional. Clear? Now, one more effect of inert gas addition. Effect of inert gas addition on equilibrium. What happens to an equilibrium reaction? R gives P by the addition of an inert gas like helium or argon. This inert gas is non-reactive. It is inert. It do not react with a reactant or product. And if you keep the volume constant, if the volume remain constant, the addition of inert gas, the gas will not involve in any chemical reaction. This is non-reactive. It do not react with the reactant or product. No effect on equilibrium. So addition of inert gas has no effect on equilibrium if we keep the volume constant. The addition of inert gas will not affect the pressure of the system. It will not affect the concentration of reactant or product because this inert gas do not react with the reactant or product. So no change in the equilibrium. So inert gas addition at a constant volume has no effect on equilibrium. Now the last topic, effect of catalyst on equilibrium. Effect of catalyst. What are catalysts? Catalysts are the substances which can increase the reaction rate. When catalysts are added in small amount, reaction rate will be increased. For a reaction R equilibrium P, if you add a small amount of catalyst, say C, into this reaction, the reaction rate will be increased. This catalyst will increase the rate of forward reaction and backward reaction in equal amount. Means rate of forward and backward reaction will be increased in equal amount. So this equilibrium will be attained quickly than the reaction in the absence of catalyst. So in the presence of catalyst, what happens? Equilibrium is attained faster. Catalyst will catalyze or increase the rate of both forward and backward reaction in equal amount. So equilibrium will be attained quickly. Equilibrium constant Kc is not affected. Equilibrium concentration is not affected. Kc value also remain constant. Only the role of catalyst is catalyst will show this reactant molecules an easy pathway, a shortcut to form product. The energy needed for the conversion of reactants to product is lowered, which we call activation energy. Activation energy needed for the reactant molecule is reduced in the presence of catalyst. Catalyst provide a new pathway for the reactants to convert into product. That means this catalyst take part in the reaction not actively. That means the reactant molecules combines with the catalyst and produce a complex, a high energy complex, that is a reactant catalyst complex. This is called activated complex. This is of high energy. Activated complex is of high energy and hence unstable. The energy needed for the formation of activated complex is called energy of activation, denoted by EA. Energy of activation. And this activated complex decomposes back to give product and the catalyst back. So as a result of the reaction, we get the product and the catalyst is regenerated back. Means the catalyst involved in the chemical reaction, but at the end of the reaction it is produced back. So this is not an active participant, this is a passive participant. It take part in the reaction passively. In the presence of this catalyst, what happens? The activation energy is much lowered. So reactants can converted to product going through an easy pathway. In the presence of catalyst, a shortcut pathway, low energy pathway for the conversion of reactants to product. Means rate of forward and backward reactions are increased. Reaction become faster. Equilibrium will be attained faster. But equilibrium constant Kc and equilibrium concentrations will not change with the catalyst. Just the speed of the reaction will be increased. In the presence of catalyst provide a low energy shortcut for the reactants to give product in a faster way. Clear, children? One more thing, if you take Haber process again, what are the conditions, favorable conditions to maximize ammonia production? How to maximize the production of ammonia? What are the favorable conditions? Two of the conditions we already discussed, which are constant addition of nitrogen and hydrogen. Constant addition of nitrogen and hydrogen will shift the reaction in the forward direction and more ammonia will be produced. Then continuous removal of ammonia. Ammonia gas is liquefied and removed from the reaction box. That also cause the reaction to proceed in the forward direction. Production of ammonia can be increased. Now, what about the pressure? High pressure or low pressure? Here you can see 1 mole nitrogen combines with 3 mole to give 2 mole. That means total 1 plus 3, 4 moles. 4 moles getting converted to 2 moles. Right? Pressure decreases in the forward direction. So, what is the favorable condition in terms of pressure? High pressure. If you apply high pressure, pressure of the range 200 atmosphere is used for Haber process to maximize the yield of ammonia. High pressure will favor the reaction in the forward direction. Because pressure, if you increase pressure, system will try to decrease the pressure, shift the equilibrium in the forward direction. Now, what is the favorable condition in terms of temperature? High temperature or low temperature? That depends on whether it is exothermic or endothermic. This process is exothermic, during which heat energy is liberated. Haber process involved liberation of heat. Exothermic. This is an exothermic reaction. So, what is favorable? Low temperature or high temperature? Low temperature. Low temperature will shift the reaction in the forward direction. But at a very low temperature, the reaction will not proceed because the reaction rate will be very low. The reaction will slow down at a very low temperature. So, very low temperature we cannot accept for Haber process. So, an optimum temperature. What do we do? An optimum temperature means a suitable temperature, not too high, not too low. An optimum temperature of around 500 degrees Celsius is selected for so that the speed of the reaction is more and the yield also appreciable. So these are the favorable condition. And at this temperature, the reaction rate also very slow, the yield is less. So in that case, here we use one more way, one more favorable factor, that is presence of a catalyst. The catalyst used in Haber process is finely divided iron. So in the presence of small amount of iron, the reaction occur faster. Equilibrium will be attained quickly. So these are the favorable condition to maximize ammonia production. In a similar way, for any system, for any chemical reaction in equilibrium, we can predict, we can determine what are the favorable conditions. Or if the change of these, how the equilibrium will be affected, we can determine based on Le Chatelier's principle.